Hello guys, in this video we'll learn how to set up dead letter queue using RabbitMQ in Rust. In a previous video I already explained you guys how to set up RabbitMQ in Rust and publish and consume messages. The code that you see on your screen right now is exactly from that video where we set up RabbitMQ, we publish the messages and then we consume those messages here. Now there is a purpose of showing you guys this code here before we start coding dead letter queue, which is I want to explain what happens if we don't have a dead letter queue and where and when we need this dead letter queue. So if we move to our consumer part right here, as you can see, each time we consume a message, we give a acknowledgement that hey, this message has been consumed. But what if the service that's consuming this message, for instance, you can just assume this parsing as a different service, is unable to parse some messages or is losing some messages, rejecting some messages. So what should we do in that case? So let's say this is down. To simulate this, I have just removed it from here. So let's see that, assume that it's down. And instead of acknowledgement here, we just reject it. Now with the rejection, we have to give one thing, which is, do we want to requeue it? Let's see what happens when we want to requeue it. Now consider this service as down, but we are consuming messages, and every time, because the service is down, we are just rejecting and requeuing. Let's see what happens. So move to your terminal and make sure you have RabbitMQ up and running. For me it is, but if you don't have it up and running, just use this command to basically reboot or restart your RabbitMQ containers. And now we will do cargo run to see what happens. So as you can see, it's basically queuing messages a lot of time, because what we are doing is rejecting and requeuing. Now this is basically just panicking your queue, which is if your service is down and you are requeuing again and again, then just imagine what will happen is a lots of messages will requeue again and again until your service is up, which may cause a lag on your queues as well, because let's say 10 messages you are consuming and then you are rejecting them, requeuing them again and again. So what happens is those messages are not lost or not getting lost, but they are creating an additional load on your queues. So instead what you can do is requeue as false. Now what will happen is the messages will start getting dropped. So let's see what happens. So just open your terminal and here again do cargo run. Now as you can see, it just prints received message and that's it. The message delivery is rejected and the requeue is false. So basically message is dropped. Now this is something that we should not be doing in a production environment, considering the scope of your system again, but at least a message drop can be a loss of message forever. So basically you would not want to reject these messages, but since the service is down, so you don't want to requeue them as well. So what's the solution? The solution is dead letter queue, which is basically having a queue that can, so basically you reject the messages from here, but there is a dead letter queue which picks them up, and then you can consume on your own requirement. You can consume, you can have a separate logic there. Maybe you can requeue there as well, but you don't want to requeue in your primary queue. That's the concept of dead letter queue. Now I hope you guys understand the concept of dead letter queue. Let's implement it. So I'll just remove all of this and let's implement dead letter queue from the start. So again, if you haven't understand the concept, just revise the video again, see the concept and then move here. So we start implementing dead letter queue. Again, no dependencies needed, just mequip is enough for us here, and make sure your Docker container is up and running or your RabbitMQ. So let's start coding. So what first of all we'll do here is we'll implement a primary consumer. So we'll say primary, or let's say consume primary queue. So what we'll do is it returns mequip result of unit, and here we'll create a mutable connection, and then we'll say connection insecure open and AMQP guest and guest again localhost 5672. So this is basically your primary queue connection, and then we'll say connection dot open channel none as the options, and then we'll say let mutable queue options queue declare options default, and then we'll say queue options dot arguments dot insert, and here we'll insert the argument of that letter Q. So we'll say x that letter exchange dot toString, and the second thing we'll provide is long string, and we'll say that letter exchange dot toString. And then the second argument that we have to add is queue options dot arguments dot insert x that letter routing key dot toString, and then we will say long string that letter routing key dot toString. So make sure you add both of these, and once this is added, we'll declare a primary queue and we'll say channel dot queue declare, and the name will keep primary queue. You can keep any name that you want. I'll just name it as primary queue and pass the queue options, and we will have a queue, and then we'll create a consumer primary queue dot consume, and we'll just use the default option. So we'll say consumer options default, and we'll just use the default consumer options, and then we'll just say let consumer is equals to primary queue dot consume consumer options default. So basically we create our consumer, and now we'll just say for I comma message in consumer dot receiver dot iter dot enumerate match message, and here we will say consumer message delivery if it's a delivery message. If it's not a delivery message, then it's other, and at the very end of this and this, and here we want to return is connection dot close. So let's complete this thing. So we will say let body is equals to string from UFT8 Lucy delivery dot body, and print ln will say receive message number with body in primary queue, and then here we'll say I body, and let's bring this, actually we don't need it, we'll just print in primary queue because we just want to receive in primary queue, and then what happens is as soon as we receive it, we'll just reject it as I explained you guys, because let's assume that something is wrong where primary queue is consuming it, so we cannot consume it, and we'll print message rejected in primary again, you can have your conditions here on what you want to reject or not reject, but I'll just reject straightforward just to show you guys how it will be redirected or exchanged to the dead letter queue. And then here we'll print consumer ended, and let's use this other, and we'll break out. So we have a connection close and everything is ready here. Consumer, okay, I think this is duplicate. Let's remove this. Yep, so everything else looks good. This should be dead letter, and yeah, so now this is our primary queue, and these are basically the settings that we provided to exchange the messages to the dead letter queue. So basically now let's go ahead and implement the consumer for dead letter queue. So we'll say consume DLX consume, and here we'll again return the same thing, mequip result, and let's go ahead and finish this. So first of all, we will again create a connection here and channel here, which I'll copy from here instead of wasting time doing the same thing. And now we will create a DLX exchange. So we'll say DLX channel dot exchange declare, and here we will provide some information, which is first exchange type, which is direct. Then we have dead letter exchange, which we will provide same as here, whatever the provided. So we'll say dead letter exchange, and then we will say exchange declare options as default. And so this is basically our DLX, and then we'll create a DLQ, basically dead letter queue. So we'll say, let's copy it from here. So instead of these options, we'll just do queue declare options dot default, and here the name should be dead letter queue. So we have a dead letter queue, and now let's go ahead and do DLQ bind. So we'll say bind DLX and date letter routing key, the routing key same as the routing key provided here, which you can also copy and paste just to confirm both places are using the same one. And then we'll just give queue declare options, we'll just use default, and that's pretty much it. And now we need the consumer again, so we will copy everything from here because we don't want to redo the same thing. And instead of primary queue, this will be DLQ. So basically we consume from DLQ, and this is not primary queue, this is a dead letter queue. So we say message received in dead letter queue, and here actually we can parse our body. So we'll say body string, let's say we are consuming letter from dead letter queue, and we can consume here. So we'll say delivery dot body. So basically we have body and width, body and body. So let's give a placeholder for this, and here instead of reject we'll say ACK. We don't need this. So what I'm trying to simulate here is we have a primary consumer which due to some reason cannot consume some messages, so it's rejecting. And what happens is immediately we'll see those messages in dead letter queue, and here you can have any logic as you want, but I am just immediately consuming those and basically using up those messages or showing up those messages. So that's pretty much it that we needed. Consumer is from this, and now let's go ahead and quickly in the main we just publish our messages. So again, in the publisher side, so I create multiple connections because I'm trying to simulate as much as the info I can do to the production environment, where we have our DLQ in a separate service, our primary queue in a separate, and the publisher is from separate service. So again, to publish it again we need this thing, and then we have to create exchange. So we'll just quickly say exchange direct, and we'll pass the channel, and then we'll say exchange dot publish new and b, and then here we publish hello world from customer, let's say, and we will publish it in a primary queue. And so basically this is our message publish, and then we will quickly create let primary handler thread spawn. So basically what I'm trying to do here is spawning both of my consumers in a separate threads, just to again mimic the behavior. So what we'll do is a move, and here we'll say if let error and consume primary queue, and we'll just println error and consuming from primary queue, and we can print those error. So this same thing we need for our DLQ. So we'll say DLQ handler, and then I'll just quickly say consume let's name it a DLQ. So we consume from DLQ, and here it is, and I print the error as a DLQ. So DLQ is basically dead letter queue. Yes, so we have handlers of both, and here I'll just say primary handler dot join dot expect primary thread panicked, some error, something wrong, and similarly we'll do for DLQ. So basically this is, since we are spawning it in different threads, so we are just waiting instead the application to close down, and then we are ending up with the close here. So we need the return type to be same as this for the main, which we'll add. So guys, this is the code that we have to do for DLQ. Now I'll just iterate over the code once for the final time before we test it. So basically assume it as three different services. One has our dead letter queue, one has our publisher, and one has our consumer. So in the publisher we are just publishing all the messages that are coming through. I'm just publishing hello world. You can publish any string that you want. And then our separate services, which is basically consume from primary queue and consume from DLQ. So what happens is all the messages come through our primary queue and we are consuming, but what happens is, to mimic the behavior, I'm rejecting those messages and setting to false. Why false? I just explained you guys in the start of the video, because we don't want to requeue in the same queue and just shoot the load. So we just reject it, and in the DLQ we are basically consuming those messages on our own time, and basically we are processing those messages. So this is the concept of dead letter queue. Now let's for the first time test it. But open your terminal, and before you test, again just check you have your Docker container of RabbitMQ running, and then just clear it and do cargo run. Okay, it works. So as you can see, it says received message number 0 in primary queue, but the message is rejected in primary queue. And then it says received message number 0 in dead letter queue with body as hello world from customer, which is the exact message that we publish. So we publish this message, and in the primary queue what's happening is we basically are rejecting this message once it's received. So it says message rejected in primary queue, and in the dead letter queue basically we consume this message and we say received message number in dead letter queue with body. So that's it for this video, guys. I hope you guys understand the concept. It's a very important concept when you work on production based backend applications and you deal with RabbitMQ queues. So it's also helped you with failovers. So I hope you guys understand the concept. I'll catch you guys in the next video. Thank you for watching. Share it with your friends and subscribe to the channel.